Good morning, Year 7. In this piece of work, what I would like to do is go through what I call the end of topic summary for this topic, which is common chemical reactions. Now, what I would like you to do is, if you go into your planner, into your Teams notebook, and in your Teams notebook, you will need to go into the common chemical reactions and then find something called the topic map. You will see this sheet. This is also in any of your areas. So I've gone into Alex's now. I've gone into his class notes. And you can see topic map, and the same topic map appears. So please use that version of this sheet. If you are struggling to find that, I will send a copy of this out attached to the Go for Schools version of it, which you can print off and add to this as you want. Now, some of this topic, and I've chosen to do this specifically, has areas in which I have deliberately left out some of the content areas. So I'm showing you here, this is the tools notebook, this is the whiteboard stuff. I've chosen the highlighter. Now what I'm going to do is say, right, I'm going to highlight this section because we've done a little bit on rusting. So in fact I might be able to just delete that off and go, we've done rusting, yes, but we haven't done much on respiration. We haven't done much on photosynthesis. We've done a little bit on combustion. We've done lots on salts, pH, indicators, endothermic, exothermic, yes. We haven't really covered tests of hydrogen because that's a practical. We haven't done tests for carbon dioxide, which is a practical as well. We have done acids and bases, acid carbon. So I've gone through it. Now what I want you to then do is possibly go back in and find with a different colour highlighter. This is yellow. The red is the ones that we don't know or we haven't done and we're not confident with. So what I'm going to say now is with the yellow one, go through the subjects in which you think you have an okay understanding on. Okay, so I think that from the topics, when we went through them, some people were struggling a little bit when we looked at the electron shells. Some people were struggling just a little bit when we were talking about the types of bonding. Most people's got the indicators all right. Some people, and I'm going to just shade this a little bit, found the idea of a pH scale a little bit difficult. So I'm just building up this idea. Then we go on to the topic and we just go, right, I'm going to choose a green now, and with my green pen, what I'm going to do with the green pen is I'm going to go through the topics. Now, so that's red, amber, green, red, yellow, green. What that does is it gives you a RAG rating. It tells me what topics you understood, and what you feel you understood, and what topics you were struggling with. That's step one of your homework. RAG rate your homework. Okay, so what I'm going to do is I'm going to very, very quickly jot these up here. So I'm going to put step 1. RAG rate your topic. Red, amber, green. Okay. Now, once you've done that, as you know, I love doing drawings. I love drawing pictures. I love coming up with ideas to turn them into pictures. So what I'm going to ask you to do is step 2 is to create a mind map. And this is going to be for revision purposes. We're not going to actually do any physical revision, but it's always a good way to summarize what you've learnt in the topic and what you think that you understand. That way then you're pulling the topic's ideas back into your head and you're just going, right, what did I understand? What did I struggle with? What did I, what do I need more help with? So I've put that down on here. And I'm going to literally just go through, right, atomic periodic table. Now, when I'm talking about the periodic table, I'm sat there, and this can be just little sketches. It doesn't need to be a wonderful piece of work. So I'm just drawing what I think is a rough version of the periodic table. Now, I'm going to say across the table, they are called periods, and the periods tell us which shells the electrons are in. And then we've got down the table are called groups, and these groups are elements with the same number of electrons in the outside shell. And if you remember, it went group 1, group 2, 3, 4, 5, 6, 7, and then the last one was group 0. Okay, so group 1 elements all have 1 electron in their outside shell. Group 2 elements all have 2 electrons. And because they have the same number of electrons, all of these behave the same way. Okay, massively important there. Okay, so I've added that a little bit in. I can change colours and I can tweak around with things and I can play with things. So for example, electron shells. And this is sort of missing out atomic structure. Because if I want to do atomic structure, I would do a picture of an atom with its nucleus. And I would draw positive, positive, positive. And then I'd draw a shell around the outside. And then I'd draw a second shell around the outside of that. That's the one thing I love about this tool, is it automatically does the shells for you and turns them into shapes, which is great. So on the first shell I can only put 2 electrons. So that's the one that's nearest to the nucleus. I put 2 electrons. And then the second shell I put 4 electrons. No, actually 1 electron, so I've only got 3 protons here. So that's 3 protons, 3 pluses, 3 electrons. So I've got now this element, I've got 3 protons, which are positive charges. I've got 3 neutrons, no charge. Now these, that's really bad drawing, it'll do, are called nucleons because they're found in the nucleus. And then I've got 3 electrons, which are negative charges, a negative charge. So I've got +3, -3, add them together, 0, in an element. Has no overall charge. So I'm going to carry on with this thing. Then we talk about charged ions. Oh, okay. What happens if I... And it's basically about losing electrons. And it's you can start to see where this topic goes, and it builds itself up. So, you know, I'm not saying we need to keep to this space. We can add to it. We can add more to it. We can change colours. So, going on to this, I'm then going to go, okay, I'm going to add to this. I'm going to do, this time, I'm going to add a little tiny bit here. And I am quite cramped for space, so I'm going to do it this way. Representing reactions using equations. So let's start off with very, very simple carbon plus oxygen goes to make, oh, this is getting in the way, isn't it? Well, I'm going to rub that and move that slightly. I do apologise for that. I would love to be able to do this. I'm going to draw an arrow down here then. Draw an arrow. Nope. So I've got carbon plus oxygen goes to make carbon dioxide. Now, big bit that we need to know about these. If it's before the arrow, these are called the reactants. If it's after the arrow, these are called the products. Remember, the reactants are the things that react. The products are the things that are made or produced. Okay, so reactants react to make. Products are the things that are made. So they will often sometimes trick you around by putting a sign where, oh, what's wrong with this word equation? And they might actually just, the word equation might be perfect, but what they'll do is they'll label these as the reactants and these as the products. Yeah, okay, they do that to trick you, but that's what they're trying to get you to do, is understand and change things around a little bit. So you got your reactants and your products. Now, when it talks about conservation of mass, the conservation of mass bit is lovely. So, conservation of mass, I've got here a carbon atom. Now, to that, I'm going to add an oxygen atom. Now, oxygen is called O2. So that's carbon, and that's O2. And when it reacts, they combine. Now, this is the bit where the conservation of mass comes in, and people make mistakes and get really confused about this, but it's simple, it's lovely, because conservation of mass says that mass cannot be created or destroyed, it can just be rearranged. So what we are saying is, if I've got this little blue dot here, which was going to weigh a certain amount, and you've got these two red dots here, which are going to weigh a certain amount, on the other side of the arrow, you've still got to have the same number of dots of each type. So I've still got one blue. I've got one blue there, one blue there. They balance. I've got two reds there, and I've got, oh, they've moved, and they are now stuck either side of this. So this is a chemical reaction because I've formed a bond, because this and this is not the same as this. But what? So I've rearranged the particles, but the particles are still there. They're not being lost. They've not suddenly disappeared or suddenly appeared from nowhere. If they appear from nowhere or they suddenly disappear, you've not conserved mass, so your equation is wrong. So you have to try and balance it. Okay, so if we say down here, and if you notice now I'm starting to use keywords, conservation of mass. I'm going to simplify this to mass before must equal mass after. Okay, that's that long-winded. Conservation of mass is matter of mass cannot be created or destroyed. It can only be changed from one. It can only be rearranged. Okay. So conservation of mass before, mass after. So if I do this and put a line down here, I've got one blue circle, and I've got one blue circle after. I've got two, so I'm doing this in a way that my pen will work on it. 2 blue, 2 red, and 2 red. And I'm going to write this. Okay, so I'm just doing stuff like that, and I'm just chucking down my ideas as I'm coming along. And yeah, okay, I might have to go back into my exercise books, or I might have to go and revise on a website, or I might have to pick up some ideas. But all of it is about recapping the topic. If you're finding yourself constantly having to go back into your notes and your revision, maybe then that's the point where you start to look at your diagram and go, okay, I had to constantly go back into my notes. So because I've gone constantly back into my notes, I'm not actually as sure about that topic as I thought I was. So I've gone back in and coloured that in for you. Okay, have a go at this. See what you can come up with. Please have a go. Email it to me. Your pictures of what you've come up with. You don't need to use the central background that I've got on here. You can add your own concept map, but I would like you to have a go. See what you can come up with. I am going to be absolutely amazed and enthralled with what you come up with. Speak to you soon. I hope you all have a fantastic holiday. As far as I know, Teams is still going to be up and running during the holidays. Email's still going to be up and running through the holidays. So if any of you need to contact me through the holidays because you're a little bit worried about what's going on and what's going to happen in September, please feel free to contact me. You know that I'm quite happy to chat and talk to most of you as you go along. Okay? I will let you go now, and I hope you have an absolutely fantastic week and holidays.